Okay, so we're going to look at gradient now and how to calculate the gradient or how to find the gradient of a line. So firstly, what is gradient? So for gradient, we use the letter M to represent gradient. I'm not quite sure why they use the letter M. I've seen reasons why given out there, but there's no real clear definition. It's just M is gradient in this case. Now the way we calculate gradient is using rise over run. So by rise, I'm talking about up and down, and run, I'm talking about across. So if we were to look at this line here, for example, that we already have put on the graph, you can see that it runs, if I went across 4, and then I went up, you could see that I would also go up 4 as well, which means it's 4 divided by 4, which we know equals 1. So the gradient of this line is equal to 1. Now, if we were to try this with a different line, I'm going to plot a few different lines on here, and we're going to have a go. Okay, here, so here is another line, and we're going to find the gradient of this line. Now, when you're finding the gradient, you need to find places where it crosses nicely on the corners of the grid lines. So we're not talking about here. We need to cross in the corner between the two grids. So this one is a quite obvious one here at 0, 0. And often I just move along the line until I find the next corner point here, which is here. And we need to see what the rise and the run in this case is. So in this case, you can see, so what we do is we look for 2 points where it crosses nicely on the corner. So I'm going to use this one here, and I could use this one here, which you usually do. I'm going to show you for an example this one here, because it doesn't really matter as long as they cross nicely on the grid line. So we need to see how much it is run in between these two. So they can see I've gone across here, I've gone across 2, and in this case I've gone up 6. Okay, now gradient is the rise over the run. Yes, the rise is 6, and the run is 2. Now 6 divided by 2, we know that is 3. And so the gradient is 3, and hey look, that matches that part in the equation over here. Let's have a look at this next line. So it doesn't really matter where you pick. So I'm going to pick a point here, and I'm going to pick a point here. And we need to see the run and the rise between these 2 points. So I can see that it ran 2 and it rose 1. So it went across 2 and up 1, which means our gradient is 1 over 2. Matches up with that number there. Cool. So for this one, we've are looking for 2 points, and you can see here I'm going to run across here, and so I ran 2, and then I want to see what I rose, and you can see that between these 2 points I went up 1, 2, 4. So the gradient again, rise over run. So we go 4 over 2, or 4 divided by 2 is 2. So the gradient is 2. Now this one's a little bit different because the line isn't going up this way anytime like it was in the other ones. It's going down. So again, I'm going to mark 2 points. Here's my first point here, and where's my next one? Oh, there it is. There. Okay. So again, we always start off with our run, and you can see we ran across 1. But now I'm not going up, I'm going down. So to represent down, we're going to go minus to go down. So we go down 1, 2, 3, 4. So it's minus 4, which means our gradient is minus 4 over 1. Which means our gradient is minus 4. Now this example here is a good example of why you just don't go across just one. You need to find where it crosses on the corner. See here, it doesn't actually cross nicely on a corner. So we can't actually use this point. And I can't use this one because it doesn't cross nicely in the corner of my grid line either. But I can use this one because this one crosses nicely. And so does this one here. So we start off with our run. And the run is across 3. And then we look at our rise, and it is going up, and our rise is 2. So our gradient 2 over 3. So the thing to remember is gradient is rise over run, and the gradient is always kind of attached to your x variable or your variable here. So it's always this bit here, look, 2 over 3, that was our gradient, -4, that was our gradient, it's attached to the x. 2 was our gradient in this one, and it's attached to the x. Half is our gradient, it's attached to that x, and 3 was the gradient in this one.